to another session. Please make sure that you write your student number in the chat. We don't have the attendance register functionality anymore. So you are requested to write your student numbers. Oh, thank you guys. I see you already did. Thank you very much. Then we can start with today's session. Do you have any question for me before we even begin? Of the 4 of you who are here today, who of you is doing 1501? I forgot about that now. I know that you told me, but is there anyone doing 1501? Discrete statistical inference or something like that. Okay, so you all here are doing 1610 or 1510. Okay, great. Okay, so today we're going to be doing study unit 5, which is discrete probabilities. Like I mentioned the last time that we might be struggling with catching up. We will have to find some way where we can do two chapters or 2 study units in one session in order for us to be able to finish the content before you go write the exam. That is on me. I will have to find out where we can find that time. Maybe we can split it into 50-50. Do one in one session and do the other one in another session. If there are no questions, then we can also continue. Like I explained, we're going to be doing discrete probabilities. So the first half, the first hour, we will look at the basic concepts of discrete probabilities and how we calculate the probability of the discrete variable. And then we're going into how we calculate the binomial distribution and also the Poisson distribution. Both of them, you can use a table, and I will show you the tables at the later stage. By the end of the session, you should be able to know how to calculate a discrete probability, how to explain or how to calculate some of the properties of a discrete probability, like the mean, the standard deviation, and so forth. Also for the binomial, how to calculate the mean, the standard deviation, and the variance of the binomial, and also how to calculate the probability. Including also the Poisson, you should be able to calculate the mean, the standard deviation, and the variance, and also the probabilities. A discrete probability, we calculate it from a discrete random variable. And since it comes from a discrete random variable, so therefore there will be an outcome that we get. And that outcome, we can calculate the probability of that outcome happening or appearing. For example, if I look at this table in front of us, it gives us the interruptions per day in a computer network, which one day there can be no interruption, there can be 1 interruption, there can be 2, there can be 3, there can be 4, or there can be 5 interruptions in a day. And once they have recorded those interruptions, then they can calculate for that month or that period how many interactions happened in that period for or how many interactions. Let's say when a day went by and there was no interruption in that day, and the probability for that will be 5. Where there was at least 1 or there was 1 interruption, the probability will be 0.25. When there was 2 interruptions, the probability will be 0.2 and so forth. And that is your discrete table. It has your X observation, with its corresponding probability. Sometimes it's written in this horizontal way, or sometimes it's vertical. You just need to know that as soon as they give you your X and your probability of X, that you are doing the discrete probabilities. So how do we calculate the expected value of the same discrete probability? An expected value is like the mean of the discrete probability. We calculate it by using the formula. The mean is given by the expected value, which is the sum of your X observation multiplied by the corresponding probability. So remember our table, which is the gray one there. It had 0 with 35, 1 with 25, and so forth. The other thing you also need to remember is the sum of all the probabilities should be equals to 1, like we've learned with the basic probability as well. So to calculate this expected mean, it means we have to multiply 0 multiplied by 0.35, which gives us 0, and 1 multiplied by 0.25, which will give us 0.25, and 2 multiplied by 0.2, which gives us 0.4. And you can do it for all of them because this is a summation. Once you have the answer for all of them, then you can add all of them up and calculate, and you will find that the mean for this data set is 1.40. And that's how straightforward it is. With that, I want you to calculate the mean of this table. What you need to also realize is there is no value for 5 interruptions, but you can calculate that value because we know that the sum of all values should be equals to 1. The sum of all values, which is the sum of X, will be equals to 1. That is our total, which is the same as total. We know that it is equals to 1, then find X so that you are able to calculate the expected mean. You have 5 minutes. When you have the answer, likewise, you can post it in the chat. Do we have an answer? Akila has an answer, so just to help others so that we save time as well. If we add all of these values, 0.5, 0.3, 0.25 plus 0.33 plus 0.1917 plus 0.15, we get 0.9. If we subtract it from 1, we get 0.10. So our x is equals to 0.1. To calculate this expected value, what we can do is we can multiply the values. So I can just do x plus px. X times px will give me the x multiplied by its corresponding probability. For 0.25, the probability of 0.25 times 1 is 0.25. 2 times 0.33 is 0.66. 3 times 0.17 is 0.3 times is 21. 3 times 3 is 3 multiplied by 2 is 5. 0.51. 4 times 5, it's 20. 4 times it's 4 plus 2 is 60. So this will be 0.60. And 5 times 0.1 will just be 0.5. And once I have all the values, I can just calculate the summation, which is that adding that value plus this value, plus that value, plus that value. And the answer we get is 2.5. And that will be our expected value. We can also calculate the discrete, before I move on, because now I'm rushing. Do you have any question? Anyone who has a question? No questions. Okay. We can also calculate the variance and the standard deviation. The variance, which is the sum of your x observation minus the expected value, which is the mean squared times its corresponding probability. And the standard deviation, which is the square root of your variance, is the square root of your sum of your x observation minus the expected value multiplied by its corresponding probability. How do we then calculate this? When it comes to calculating the standard deviation or the variance, because it's a long calculation, this is one way that I will say you might want to do, is to create a column where you do this first part of the calculation. Once you have the answers for every part of the calculation, then move on and to do multiplying it with the corresponding probability. And that's what I did here. So from the data that we have, remember we calculated the expected mean. Our expected mean found that it was 2.5, this is the other exercise that we just did. It was 1.40, 1.40. We calculated that when we did the example. So we're going to take our x observation, subtract it from the mean, and square the answer. And once we've squared the answer and have all of them, then we take those answers, we multiply by the corresponding probability. And that is the next block that I did. So starting with this, we say 0 minus 1.40 squared, and that is the answer. 1 minus 1.40 squared, we get 0.16. 2 minus 1.40, we get the answer, and we square it, we get 0.36. And you do for all of them. Once you're done, we say 1.96 times 0.35, we get the answer. 0.16 multiplied by 0.25, you get the answer. And you do for all of them until you get all of them, all the answers. Once you have all the answers, remember you are just doing what is underneath the square root, which is just the variance. We calculated what the variance is. Once we have the variance, so which means we've calculated the variance, which is 2.04. Once we have the variance, then we can take the square of the variance, the square root of the variance, and that will give us the standard deviation. Any questions? If there are no questions, then you have an exercise. Calculate the standard deviation of this answer. So what you need to do is first, if you can, try and do what is inside the bracket. Calculate that and square the answer. Once you have done with that and you have your answers, then you can multiply by the corresponding probability. Remember our mean for this exercise, our expected value, which we calculated, 2.5. And if I can continue here to write it. So if we go and say x minus px, and maybe probably you can do but on your calculator, it's easy if you do the square immediately after getting the answer. It will be great. Which will be 1 minus 0.25 equals 0.75. And when square of that answer, get 0.05. You need to write them all up. Don't just write 3 digits. You must write all of them. And remember, this is equals to 0.1. Then you continue and do the next one, which is, I did that one wrong. Let's rewrite this again nicely, so that we have enough space. So this is x minus the expected value squared. So it will be 1 minus 2.52 squared, which is minus 1.52. And then you take the square of that answer, which will be equal to 2.3104. Then you do the next one, which is 2 minus 2.52 equals minus 0.52. And you take the square, and that will give you 0.2704. Then continue with the rest of them. How far are we? Sorry, Nadine, are you not hearing me properly? I think that's the network issue. Let me see. Okay, let's see if we can get the answers. You must let me know if I am having the answers wrong as well, because I'm doing them in a hurry and you must be my sounding board. So for 3 minus 2.5 squared, you will get 0.2304. And for 4 minus 2.52 squared, your answer you will get will be 2.1904. And for 5 minus 2.52 squared, you will get 6.1509. Agree? Now, since we have all of them, then we can take those values and multiply by our corresponding probability. So we'll take that and multiply it with the corresponding probability. So we'll take 2.3104 multiplied by 0.25. And the answer we get, I'm sorry, I'm going to write them like vertically since I'm going to run out of space. And that will give us 2.3104 multiplied by 0.25. 0.25, we get 0.5776. I hope you all get the same answer. And 0.2704 multiplied by 0.33, we get 0.08. 0.08932. And for 0.2304 multiplied by 0.17, I get 0.039. 0.039168. And the next one is 2.19 0.04 multiply by 0.15. Multiply by 0.15, I get 0.32856. This will be 0.32856. The last one, 6.1509 multiply by 0.1. Multiply by 0.1, I get 0.61509. 0.61509. Now, since on this formula, I'm missing the summation. Since the standard deviation is the sum of your x minus the expected times the corresponding probability, therefore we're going to use these values here at the end. We're going to add all of them together, and that will give us the standard deviation will give us 1,640. Let me write it nicely. 1,6496. That will be the answer that we get when we add all of the values. And when we take the square root of 1,6496, we get, I get 1,28. What do you get? Any question? Anyone who got different answers to me? Shakila, you got 2.6, or was it for the other question? I'm assuming it's for this one.
Yeah, I got the answer wrong.
Okay.
No, it's okay. I see. I know where I went wrong.
Okay, no problem. As long as you saw where you went wrong, it's fine. But I was wondering, did I make the all the calculations correctly? Does it correspond to what you guys have in front of you? If not, let me know so I can fix, because these are long calculations that we are doing. And if everybody has the same answer as me, then I am good. We can move on to the probabilities. So now, any question before I move on to the probabilities? I'm making this easy for you that you don't have to talk to me for now, but as we go along with the session, I will ask you to do the exercises and give feedback to one another as well. Okay, so do you have any questions? If there are no questions, then we can move on to the probabilities. How do we calculate probabilities of a discrete probability distribution? So before we get to calculating the probability, then there are a couple of things that I want to highlight. Sometimes when even going forward from now on until you go, we finish off with the content, you will read somewhere where they talk about words like at least, less than, more than, at most, greater than, between. You need to know what those words mean in terms of mathematical signs or symbols, because they have a meaning to them. They mean something. So for example, if in the question they say it is exactly or it is equal, it means it is exactly that number. If we have, for example, remember our table, I'm going to use it going forward as well. Remember, it has days, interruptions per day, and the corresponding probabilities. So let's say we want to calculate the probability that number of interruptions that will happen in a day is equal to or is exactly that. If we say it in a probability function, we'll say what will be the probability that an observation or an interruption will occur exactly. There will be two interruptions happening. What will be the probability that there's exactly two interruptions happening per day? And that is, if we look at this table, I will interpret it because it says equal. Therefore, it means it will be 0.2. That will be the probability of equal. If they say, what will be the probability that less than or fewer than or below 2? What will be the probability that there will be interruptions below 2 happening, or fewer than 2 happening, or less than 2 happening? Therefore, it means they are saying what is the probability that x is equals to 0 plus the probability that x is equals to 1. Because it says what will be the probability that fewer or less than, and the only thing that are less than 2 are 1 and 0, not including 2 because it says fewer than or less than. And therefore, this will be 0.35 plus 0.25, which then gives us 0.60. And that is the probability of less than. Same will apply when they ask the probability of greater than or more than. It means does not include that number, but it will be more than 2. So it means we will include, if it says the probability will be x will be more than 2, it means not including 2, but everything bigger than 2, which is 3, 4, 5, which then will be equals to 0.2. What will be the probability that at most 2, let's put it this way. What will be the probability that at most 2 interruptions will happen in a day? That means what will be the probability that x will be less than or equals to 2? It must include 2. So it will be the probability that x is equals to 0 plus the probability that x is equals to 1 plus the probability that x is equals to 2. Because that is the probability of less than or equal, which then means it will be 0.35 plus 0.25 plus 0.20, which then it will be equals to 0.80. And that is the probability of at most or no more than or less than or equal. What will be the probability that at least 2 or 3 interruptions will happen in a day? Probability that x is greater than or equals to 3, which is at least 3 interruptions will happen in a day. It's given by the probability that x is equals to 3 plus the probability that x is equals to 4 plus the probability that x is equals to 5, because they are only up until 5. And therefore, it is 0.10 plus 0.05 plus 0.05, which is equals to 0.20. That is the probability of at least. Those who are doing 1610, in your study guide, there is some way closer to the probabilities, or maybe basic probabilities, or when we deal with the discrete probability in your study guide. I am not sure if the study guide is updated. There, you must look there, the symbols and the meaning are jumbled around. So you must make sure that you use the correct meaning of the symbols as well. You can just fix those ones with the correct ones that I'm having on this on this screen. Okay, so now we move on and we go into the between. So what will be the probability that X will be between two values? Here the challenge is when they say between, normally when they say between, we assume that it also includes those values. So we do it as an inclusive. In general, when they say X is between two values, we in general say it's between 1 and 2, so therefore it will include 1 and it will also include 2. So when you do discrete probabilities, they have to tell you explicitly to say X is between inclusive or exclusive, because there is a difference. When it's inclusive, it will include the two values. So let's say X is between, what will be the probability that X is between inclusive? X is between 2 and 4. So that means X is between 2 and 4. And since it's inclusive, it means we're looking for the probability that X is equals to 2 plus the probability that X is equals to 3 plus the probability that X is equals to 4, because it is inclusive. It says it's between 2 and 4. And everything that is between 2 and 4 included with the outer and the upper boundaries is 2 and 4. So we need to include them. So the probability will be equals to 0.20 plus 0.10 plus 0.05, which then the probability is equals to 0.35. 0.35. And that is the probability of between inclusive. What is the probability of between and it is exclusive? So when they say exclusive also, they need to tell you, unless if they give you their functions themselves, like the in symbols itself. If they say inclusive in general, it means both sides will be not equals to, will not have an equal sign to them. So let's say, repeating the same question that we did, the probability that X lies between 2 and 4, and this is exclusive. We're doing exclusive. Therefore, this says X is between this value and this value, but it does not include those two values. Therefore, the probability that X is between 2 and 4 is the same as the X is equals to 3, which then it is 0.110. If it was between 2 and 5, then it will say 3 and 4, and we will say it is 0.15. That is in exclusive. But if they give it to you in a symbol, it makes it easier, because sometimes they will say they can have both of them, the inclusive and the exclusive in one formula. So it will say, what will be the probability that X lies between 1 and 4, and it is less than 4. Therefore, what did they mean by this is they are saying X is bigger than, the value of X is bigger than 1 including 1, it's 1 or bigger than 1, but it is, since this goes that way, but it is less than n excluding, so this won't include it, but it is also less than excluding 4. So therefore, this will be the probability that x is equals to 1 plus the probability that x is equals to 2 plus the probability that x is equals to 3. I hope you get my point, which then is 0.25 plus 0.2 plus 0.1, which is 0.55. That will be the probability. And with that, you have an exercise to do. What is the probability of more than? You remember what more than is? More than, it is greater than. What is the probability that X will be between 2 people, 2 and 4 people, and this is inclusive? And what is the probability of less than 3? You have up until 6 o'clock, and when we come back, we recap and do feedback on the 3 questions that we have. If you have any other question, feel free to ask. Okay, how are we doing? Did we find the answer? Let's work through them. Okay. Roslyn says 0.1, 0.5, 0.58, and I think everybody agrees with the answers. So let's look at what did we do. So what is the probability that X is more than 4, which is greater than, it means it's only those ones. Remember, this was 0.1. So therefore is the same as the probability that X is equals to 5, which is equals to 0.1. The second one was asking what is the probability of between and it's inclusive. So the probability that X is between 2 and 4, meaning it's between those two, is the probability that X is equals to 2 plus the probability that X is equals to 3 plus the probability that X is equals to 4. And that is 0.33 plus 0.17 plus 0.15, which is equals to 0.33 plus 0.17 plus 0.15 is equals to 0.65. The next one, which is the last one, it says the probability that it is less than, not greater than, but less than 3 people per household. And that will be the probability that X is equals to 1. There is no 0 there, so you start with what you see on the table. It's 1 and 2 because it does not include 3. That will be the probability that X is equals to 2, which then is 0.25 plus 0.333, which then is 0.58. And that's all what you have. Any questions? Now we move on into the binomial distribution and the Poisson distribution. When we work with the binomial distribution, you can use your formula or you can use the table. The easy way, when they ask you questions about the probabilities, is to use the table. But sometimes they just want to see if you understand how to substitute into your formula. Therefore, then it means you need to know how to put values into that formula to calculate the binomial. Otherwise, try by all means, do not try and calculate binomial distribution using formulas. You can rely on the tables. You will get the tables because they will be in front of you since you're also writing online. And even when you were going to write the venue-based exam, the tables would have been given to you at the back of your exam papers. Like if you go on My UNISA, there are past exam papers. At the back of those past exam papers, there are tables. If you do not have a prescribed book or the table, the tutorial letter that has the tables. Those who are doing 1610, the tables are also at the back of your tutorial letter 101. Okay, so what is binomial distribution? Since it also comes from a discrete probability, but this, we look at the outcome, and those outcomes or the trial or the event has to be from an identical trial. has to come from the same sample space, and there will always be two outcomes, a success or a failure. And the probability for success, we denote it by the pi, and the probability for failure, we denote it by 1 minus pi. For example, when you toss a coin and it lands on a tail, we can define the probability of success as a coin landing on a tail. And when I toss the coin and it lands on a head, then I will be calculating the probability of a failure. And the two events, the head and a tail, or its success and failure, have to be mutually exclusive. They cannot happen at the same time, but they need to be collectively exhaustive. And we did this when we did the basic probabilities. And also, the trials or the events that are happening, they need to be independent events. None of them should be affecting the other outcome that needs to happen. Since when you write the exam, you're not only going to write theory, but calculations instead. You are also expected to do theory and understand how the questions are asked in terms of the theory. Here's an example. Which one of the following statement is not a true property of a binomial distribution? So we said trials must, an experiment must occur from a trial. Experiment or trials must be independent. Events must be mutually exclusive but collectively exhaustive. There should be two outcomes, two possible outcomes, a success and a failure, which are mutually exclusive. And then the other one, so since there are only two outcomes, a success or a failure, so the probability of either one happening will always be a 50-50 split, which will always be a 0.5. Therefore, the only thing there that is not a true binomial probability is, or binomial distribution property is, the probability of success remains the same for all the trials. Nope, it does not remain the same, because if you have a die, the probability will be different. If you have a stack of cards, the probability will be different. And that's how all of them will be you will be able to answer those questions like that by understanding the basic probabilities. Okay, so another example, this was supposed to be your exercise. Africa check found that sources of fake news on Facebook are mostly ghost profiles. Suppose that 20% of the profiles on Facebook are ghost profiles. Suppose further that we randomly select 20 Facebook profiles and check whether those are ghost profiles or not. Which one of the following statement is incorrect? So yeah, this, they don't require you to do any calculation. It's just a theory question to see if you understand everything about binomial distribution. The first thing that you need to realize is they give you 20%, which means this is your probability of success, regardless of whether they're talking about ghost profiles or not. So they will give you your probability of success. The other thing, they will tell you how many number of trials you ran from this. So then the question is asking you, which one of the following statement is incorrect? So in the next 2 minutes, I just want you, with me being quiet, I want you to look at those statements and find out on your own, and then I will confirm if you are right or wrong. Which one of those statements is incorrect? And your 2 minutes starts now. Do we have an answer? Do you know which one? So let's look at the first one. Given the information described, a binomial experiment with possible outcome, ghost or not a ghost. That is a binomial property. We know that. But as long as they tell you there are two outcomes, then it will follow a binomial distribution pattern. The number of trials is 20. Yes, they told us that they randomly selected 20 Facebook profiles. The 20 trials are independent of each other. Yes, they have to be, because then also one does not depend on the other. Number 4, the probability of success of the ghost profile is 20 trials. Can it be 20 trials? No, it cannot be 20 trials. It has to be 20%. So that question, that is the incorrect one. This is the incorrect one, because it is 20% of Facebook profiles that are ghosts. The probability of failure is 0.8. Yes, because the probability of success, if it's 20%, therefore 1 minus the probability of success will be 1 minus 0.20, which is equal to 0.8, which then means the probability of failure of the probability of not a ghost profile will be given by 0.8. And that's how you will answer the questions when it comes to the binomial distribution. Now we move on to the binomial distribution characteristics, which are your mean, your standard deviation, and your variance. The mean is your expected value, which is your trials multiplied by the probability of success. Your variance and your standard deviation. Your variance is n times the probability of success times 1 minus the probability of success. The standard deviation is the square root of your variance. If we look at the previous slide that we were looking at, if we look at the previous slide, let's say we look at the previous question that we had of ghost profiles, this one. If we take probability of success as 20% and the trials as 20, let's go calculate all the other characteristics. So we come here, we want to calculate the characteristics. So we know that our probability of success is 0.2 and our n is 20. To calculate the mean, which is the mean, is your n times the pi, which is 20 times 0.2, which then gives us 0.2 times 20 gives us is equals to 4. 20 times 0.2 gives us 4. Calculating the variance, which is sigma squared, we know that it is 20 times 0.2 times 1 minus 0.2, which is 1 minus 0.2 is 0.8 times 0.2 times 20 equals 3.2. That is the variance. Calculating the standard deviation, which is the square root of your variance. The square root of our variance, and we know that our variance is 3.2. We just take the square root of the answer, and our standard deviation is 1.779 if I leave it to 2 decimal. And that's how you calculate the binomial distribution characteristics. That is your exercise, 5 minutes. Then we move into the probabilities. Actually 2 minutes because it's as quick as it can be. 2 minutes. Calculate the expected value. If you calculate your expected value, which is n times pi, calculate the variance, which is n pi times 1 minus pi, calculate the standard deviation, which is the square root of your variance. Calculate those. Calculate those. You have 50% and 6 people. Your probability of success is 50%, your n is 6. Should be easy. What's the answer? Shakila, I'm assuming your number 2 is, your answer 5 is for this question that we are looking at. Others? Okay, if you calculate 0.5 times 6, you get 3, which then means this is correct. Then when you calculate the variance, which is 0.5 times 6 times 0.5 again, you get 1.5. Maybe let me write them here. So this will be 6 times 0.5, and this will be 6 times 0.5 times 1 minus 0.5, which is the same as 0.5. This will just be 1 minus 0.5, which is 0.5 again. And the answer you get will be 1.5. And the square root of 1.5 will give you 1,24744,871, which then you can round it up to 3 decimals and it becomes 1,225, and which makes option number 5 the correct answer. Any questions? If there are no questions, let's move on to the probability. I just brought back this slide so that you can remind yourself that the probability, if they don't give it to us in a symbol form or a mathematical function format, then we can use the word, create our own symbols of functions. This is the formula to calculate the binomial distribution probability. The first part of the equation, which is this, is a combination function, which tells you the number of ways you can do things. And the second part of the equation tells you what will be the probability of doing those kind of ways, things in those kind of ways, number of ways. So if you like betting lotto, you can use this to guide you in terms of the number of times you will win lotto if you bet lotto using random numbers, like the same number every now and then. And this will give you that, because we know how many number of times the chances are. Those are the trials, how many number of times the lotto will run. You can put it there. How many outcomes you need, and what will be the probability of you winning lotto. You can calculate it. It will be 1 divided by how many balls they have, 49. So you can say 1 over 49. That will give you the probability of success, and then the rest will be your probability of failure. And you can calculate your chance. And if it's worth it, then you can go bet lotto. If not, then you can decide to save your money and get interest. Okay, so how do we then calculate the binomial distribution? So I showed you the formula, and I said in the beginning, when we started with the binomial, I said you can use tables, and this is one of those tables. The binomial distribution table has two sides, has the two tables. It has the probabilities at the top, and it has the probabilities at the bottom from another page. They both work in conjunction with one another. The probabilities at the top here at the top of the table corresponds to the x values and the n values on your left. So when you look at the binomial distribution table, when you put it up, the values at the top, which are smaller probabilities, they correspond to the n and the x observations on your left. Even on the next page, when you read 0.2, you must read it with 10 from the second page from the left. So when you look at the second page, please don't turn it around and try and make sense of it in that manner. You must always know that at the end of this question, of this table here at the bottom, is the opposite of 0.09. That will be 0.99. The same way, when you go to the second page of the binomial distribution, there will be values of probabilities at the bottom of the table, but we read them with the values on the left. So if the probability was 0.75 and n was 2, we go 0.75 and n, we go look for n on this side. And we go look for n is equals to 2 from this side. You don't go to the left side. You stay in the right-hand side. And that's how the probability distribution table works. So let's look at how we calculate the probabilities. So let's say 1 in 5 observation if the probability of an event of interest is 0.1. So we know that our x is 1, our n is 5, and the probability of success is 0.01. Find the probability of x is equals to 1 is easy with the formula because you only are calculating for the one thing. So we substitute the values onto the formula. N is 5. So 5 factorial divided by x factorial, which is 1, times 5 minus 1 factorial, times the probability of success, which is 0.1, to the power of x is 1, times 1 minus the probability of success of 0.1, to the power n minus 1, which is 5 minus 1. Substituting, calculating, and the answer we get is 0.32805. If we need to use the table, we could have saved a whole lot of time, because let me see if the table that I have has the values we need. My computer is stuck. Apologies for that, because my computer is not responding. You just have to wait a bit. Is it back? Okay, it's back. So 0.5, no, I don't have it. So I'm going to go out of this slide. Going to go out of the slide. And remember that. I'm going to share your table. Hope you are able to see the table. So I'm looking for 0.1, which will be at the top, and that will be 0.1. Remember, we're looking for the pi of 0.1. We're looking for n of 5, and we're looking for x is equals to 1. And you know that we're looking for the probability that x is equals to 1, which makes it easy. So we go look for n. N is 5. We already found what our pi is. We look for n. And we also look for x is 1. And where they meet, that will be the probability that we're looking for. And there we go. 0.3280. Easy, straightforward, easy to do. But what happens if it was the probability of x is less than 1? If the question was asking us to the probability that x is less than 1, so therefore it means, okay, not responding again. Just give me a sec. I think my frozen. Seeing my screen. I'm going to stop sharing because it's frozen. And then I'll go back to the presentation. And doesn't allow me to stop sharing because it's frozen. Okay. I hope you are able to see the presentation now. We'll use the presentation to do the exercise. Same thing that I wanted to do. So let's say, for example, we want to find the probability that x is less than 1. But now, since I don't have the other information, I'm going to change and say our pi is 0.05. Let's use that. And our n is equals to 4. So we know that we're looking for the probability that x is less than 1. Therefore, we're looking for the probability that x is equals to 0 plus the probability that x is equals to 1, because it says, oh, let's say it's less than or equals to, since I wrote it like that, I included that. So let's say we want to find the probability that x is less than or equals to 1. Therefore, we're looking for where x is 0 plus where x is 1. And we need to go to the probability of success where it is 0.05. And we're going to look for n is equals to 4. And the probability, and that will be those two values there at the top. So if I look at it, it will be those two values. Therefore, it will be 0.8145 plus 0.1715. And that's how you will find the probability of a binomial distribution. So it will be 0.8145 plus 0.1715 equals 0.986, and that will be equals 0.986. And that's how you will go and find the probability. If you were going to use a table, the formula, you will have to do this twice. So you will do the probability of x equals to 0 and the probability of x is equals to 1. So then you will add them together and do the same. X pi times n minus x factorial n. So you will do two of these equations and add them together so that you get the same answer. So it's easy to use the table, especially if you're going to do the greater than or less than or the less than or equal and so forth. And that is binomial distribution. I'm not going to ask you to do any of the exercises, but you can look at the questions you got in your assignment and see if you can answer some of those questions. I just want to go to Poisson distribution. Do you have any question? Any question? If there are no questions, then we move on to the binomial or Poisson distribution. A Poisson distribution tells you the number of times an event will occur given the area of an opportunity that thing will happen. And that area of an opportunity is always a continuous or a interval time unit, like the number of mosquito bites on a person, the number of computer crashes per day, the number the bus passes per the intersections per day, things like that. They always are going to be numerical and also of an interval fashion. The characteristics of Poisson distribution are the mean, the standard deviation, and the variance. So the mean is your average expected value, which is your mean is your expected value. It is your lambda. That sign is called lambda. So the mean is your expected value. It is your lambda. The variance is the same as your expected value or your mean or your average or your lambda. And the standard deviation is the square root of your variance. Always standard deviation is the square root of your variance. So let's say we want to calculate and the mean average is 3.5. So our lambda is 3.5. If I want to calculate the mean will be 3.5. If I want to calculate the variance will be 3.5. If I want to calculate the standard deviation will be the square root of 3.5, which then becomes the square root of 3.5 the square root of 3.5 is 1.8771. That will be the characteristics of the Poisson. Easy, straightforward. I've already calculated this. I'm going to change it around. So let's say it is 4. Calculate, find the mean, the variance, and the standard deviation. You have 2 minutes to do that. Okay, that was an easy one. Let's see the responses. The mean, the variance, and the standard deviation, where are your answers? Or you can say them out loud. You can unmute. What is the mean? Am I alone here or what? Do you guys hear me? Or maybe I'm speaking to myself. Am I muted? No, I'm not. Guys, what is the mean, the variance, and the standard deviation?
The mean is 4, and the variance is also 4, and then the standard deviation is 2.
And the square root of 4 is 2. And that's how easy it is. I was going to ask you to do this exercise. No more. No. Let's go into the probabilities. To calculate the probability of a Poisson distribution, we use this formula, which shows the x as your expected events and your lambda as your average or your expected number of events, and your e is your base natural log of the system. On your calculators, you do know where the e is. If you are using a sharp scientific calculator, it is that e with an x. If you are using a Casio, you will also be able to see that e with an x. And we just solve the equation. Also, like with binomial, Poisson distribution, you do not have to use the formula, but they will want to know if you know how to substitute the values into the formula. We can use the table to answer the question. So if we need to find the probability that x is equal to 2, where the average is 0.5, you can go to the table and say x is 2 and the lambda is 0.5, where they meet. That's the value you are looking for. Or you can use the formula by substituting. E is the system function, so you don't have to substitute it. Lambda is 0.5, 0.5 to the power of x. X is 2 divided by x factorial, which is 2 factorial. And when you calculate and solve this, you will get that it is 0.0758. The only challenge with this as well is if you need to calculate the probability that x is greater than 3. So therefore, it means you need to find the probability of x equals to 4 plus the probability of x equals to 5 plus the probability of x equals to 6. Since this table ends at 5, you can do up until 5. But if I look at the values, you can see that 5, 7, and 6 are 0. So I don't even have to include them. So you will just add 0,0016 plus 0,02. So this will be 0,0016 plus 0,00002, which is equals to 0,0018. And that's how you will do that. Otherwise, if you were going to use the formula, you were going to do for 4, answer the question, and do for 5, answer the question, and then add them all up together. Up to you how you want to go through your exam. Remember, you will only get one question relating to Poisson and one question relating to binomial distribution. So it's best to use the table than to suffer and do things manually as well in the exam. But there is no harm in trying to use the formula as well. With that, oh, maybe I should explain the binomial distribution table. I hope my table is back up, so it's fine, it's back. I just want to share again the screen to explain the binomial distribution table so that we all can see, or the Poisson actually, sorry. I want to share the Poisson distribution table. Just give me a sec until I get to the table. Okay. Let me share. I hope it's not gonna freeze on me. So this is your binomial, your Poisson distribution table. It looks like this. It is broken down by the lambda values. So you can see that your lambda value starts from one table, starts from 0.1 until 1, and it has its own corresponding x values. And each table is different because the x values, they increase with each lambda value. So this one, with the first one, it starts from 0 until 7. The second one, it starts from 0 until 9. But they all are broken down by in terms of your lambda value, your average value. And you will see that all the tables are different. So you just need to make sure that you know how to read the question. So if they wanted you to find the probability that x is equals to 4 and your lambda, sorry, not the pi, but your lambda or your average value is equals to 4.5, then you will come to 4.5 and you will go to 4 where they meet. That will be your probability. If they said it's greater than or equals to 4, then it means you have to add all of them. That's the other thing I want to also share with you. So let's say your lambda is the same as what we have. I just want to change the question a bit. Let's say they say it is greater than or equals to 4, where lambda is equals to 4.5. So we know that they say it is greater than or equals to 4. It means it has to include 4 and go in there. If you look at those values, there are so many of them. You will take forever trying to answer the question looking at this. You can also do the opposite and say it is 1 minus the probability. This will be the same as 1 minus the probability that x is less than 4, which then means it's 1 minus into bracket the probability that x is equals to 3 plus the probability that x is equals to 2 plus the probability that x is equals to 1 plus the probability that x is equals to 0. Therefore, it means instead of adding 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 values, you're just going to add 1, 2, 3, 4. 4 values and subtract them from 1. And that will give you the probability of greater than 4. Any questions? If there are no questions, I'm going to go back to the slides. Then after that, we recap and then as if like I'm unable to get back to my slides. Sorry. So reshare. Can you see the slide? Is it visible?
Yes, we can see.
Okay, great. There is your exercise. I know it's written example, or actually let's go to the real exercise. Just want to demonstrate something with this exercise. So this is one of the other questions that you might get in the exam. It looks like this. It says, here is the average distributed mean. It follows a Poisson with an average mean of 1.6. What is the probability that on any given day, a neuropsychologist will consult with only one adult with ASD? And they're asking you which one of those statements is correct. If you are not aware, you might quickly jump into the table and start calculating the probabilities. Now, remember, only if you use the table, you will be able to answer option number 1, number 2, and number 3. So this, you can go to the table. On the table, you go look for lambda 1.6 and your x equals to 1. Easy. Easy, easy, easy to go find on the table. If you don't find the answer, still fine, because you still have 2 more options. The fourth option, they're asking me, do you know how to substitute if you need to substitute into the formula e to the power minus lambda times lambda to the power of x divided by x factorial. That's all what they're asking you to do. Can you substitute into the formula? Easy, because x is 1. So therefore, it means where I see x, I'm just going to put 1. And my lambda is 1.6. Where I see lambda, I'm going to put 1.0, not 6, but 5, 1.5. I will put 1.5. So this will be e to the power minus 1.5 multiply by lambda is 1.5 to the power of x is 1 divided by, maybe I should write this properly as well, 1.5 to the power of 1 divided by x factorial, which is 1. So if you look at this, it's the same as that, even though I'm writing it the other way around. So what they did here, they said lambda x e to the power negative lambda divided by x factorial, which is the same as what we have. We just swap the values around. 1.5 to the power of 1 multiply by, because this is lambda multiplied by e, so multiply by e to the power minus 1.5 divide by 1 factorial. If you look at those two, they mean one and the same thing. And this is the answer to the question that they were looking for. Trying to complicate your life, but you just need to have an open mind to say, oh, probably maybe they want me to calculate the probability or substitute into the formula. They don't want you to calculate it, but they just want to see if you are able to substitute into the formula. Any question? Because then with that, it concludes today's session. I will see you next week, Thursday, when we do normal distribution. Those who are doing 1501, I am not covering with this segment. You can see that time went by quick. What we didn't cover here is the bivariate distribution. Easy with the bivariate distribution. I will post in your group how you solve the bivariate questions. I'll just give you an example, and if you have any question, you can then just ask. With that, then it concludes today's session. I can just recap on what we did, and then the session will end. Just to recap, since we did a lot of things, we discussed the probability distribution of a discrete variable. We looked at how we calculate the mean, the variance, and the standard deviation of the discrete probability. We looked at how we calculate the probability of a discrete variable. And then we also looked at how we calculate the mean, the variance, the standard deviation of a binomial distribution. And we also looked at calculating the probability of a binomial distribution. And I said, you can either use the formula or you can use the table. It will be easy if you use the table because it will save you a whole lot of time. We also looked at how we calculate the mean, the standard deviation, and the variance of the Poisson, and how we calculate the Poisson distribution probability by looking at whether we're using the formula or we're using the table. Also remember, every time we work with probability and they give you the weights, probability of at least, probably at most, you need to know that what do those mean in terms of the mathematical sign or symbol, so that you are able to complete your questions correctly. With that being said, thank you guys for coming through. I will see you next week, Thursday. Good night and enjoy the rest of your evening.